Here is a quiz 2 review where we're going to do a couple multi-step significant figure calculations and convert a large number and small number to both scientific notation and engineering notation. I'm going to solve two problems using multi-step significant figures. So first I'm going to write what is in the parentheses or add what is in the parentheses. If I were to add those up, that is going to be 57.239. When you add numbers, you go with the least amount after the decimal. So, although my answer would be 57.24 at this point, I'm going to underline where I would normally stop, but I'm not going to round until the end. So in sig figs, you do not round until the end for multi-step things. So although, again, the answer would be 57.24, because I would round up due to that 9 after that, I'm not going to round until the end. But I'm going to make note of where I would have rounded to if I were to round. Then I'm going to multiply by 2.10, and when I do get that, I get 120.2019. If you were to go back, you would see that I multiplied 57.239 times 2.10. I did not multiply 57.24 times 2.10. Now this is a good one because you're going to see that we're going to have to write it in scientific notation, and that's because when we multiply numbers, we go with the least amount of sig figs. That top number, since we're not supposed to, but since in theory we did round at 57 and 2 decimal places, that would be 4 sig figs. And down here we have 3 sig figs. So the answer has to be 3 sig figs. So you're not rounding until the end. But I do make note of where I would have rounded if I did round, to what place I would have rounded if I rounded. That answer there is then for sig figs, 120 point. I have to put that point because I need 3 significant figures. Now that is acceptable. However, what would be ideal is 1.20 times 10 to the second. If you enter that in your calculator, you're going to get 120. Both have 3 sig figs because zeros at the end of a number are significant if there's a decimal. So again, we're not rounding until the end, but we're making note of where we would have rounded if we rounded. So it's about seeing that pattern and being comfortable with the number. Now here, multi-step, significant figures. I'm going to do what's in the parentheses first, and I'm going to write out what that would divide it to. I'll just write out every number that the calculator says, but you can just keep that number in your calculator because you're not rounding until the end. But I'll write it out because you'll see what we have to do. Now, if there was an answer to this, I would round to 2 sig figs because you go with the least amount of the numbers being multiplied or divided. Therefore, I would round to 2 sig figs, but I'm not until the end. You do not round until the end. But I'm just going to make note of it that I would have rounded to 2 sig figs. Whether I would have rounded up or down, I guess, really doesn't matter. So in that last example, I sort of said we would have rounded up, but I guess in this, it doesn't matter what we would have rounded to, but I just make note of it. Then I subtract minus 0.11. So I'm keeping that in my calculator, and I go minus 0.11, and I'm just going to write out what I get. 0, 3, 8, 8, 6, 0. I mean, we know it can't be that many sig figs, so I'm just going to round that out. When we subtract, we go with the least amount after the decimal. In that top number, there's 2 after the decimal. In that bottom number, there's 2 after the decimal. Again, there's 2 after the decimal in that top number, even though I did subtract from that full number. But if we were to answer at that point, there would have been 2 after the decimal. Therefore, I need 2 numbers after the decimal. 0, 4. Now this is also a good one, and I picked it for a reason in the sense that we have that 0. You can say that's not a significant figure. However, when we subtract and add, we don't even care about sig figs. We're going with the least amount after the decimal. So now let's look at scientific notation. One thing to always look at, and you'll get more and more used to this, but if a number has units on it, you want to include units in your answer. Very rarely will there ever be numbers without units on them. A number without units really doesn't mean anything. So make sure that if units are asked, or especially if there's units in the question, you use units in your answers. Another thing about scientific notation is we're going to keep the same amount of significant figures as there is in the measurement. If you write a measurement in scientific notation, you don't want to change the measurement. Therefore, the significant figures in the measurement will remain the same. This number has 5 significant figures, as zeros in between non-zeros are significant, and zeros at the end of the number are only significant if there's a decimal. Therefore, when I write it in scientific notation, I need to keep 5 significant figures. I'm going to move that decimal from in front of, because in any number there's a decimal. If it's not there, it's going to be all the way at the end, to the right of the first non-zero. And if we count that up, I moved it 10 times. So in scientific notation, that is times 10 to the 10th liters. Notice there are 5 significant figures in that answer. Now we have to put in an engineering notation. In engineering notation, the front number has to be between 1 and 999, meaning that front number can't be 0. It can't be more than 1,000, but that tends not to be an issue that students have, but students do sometimes move the decimal to make that front number less than 1, because it is easier to get to the power of 3, 6, or 9 that is being asked of them. For this one, the closest number is 9. I have to lower that 1. Since I have to lower that 1, I'm going to increase that number. Hence, I'm going to make that number larger. Therefore, I can rewrite that number as 10,101 times 10 to the 9th liters. Meaning kilo 3, giga 6, mega 6, giga 9. Notice there's still 5 significant figures. Being that giga is 9, we can then replace that 10 to the 9th with giga. So we have 10.101 gigaliters. So going back to this one back here, I knew that I had to make this number smaller, and in a sense, I knew I had to make this number bigger. I couldn't make that number smaller because then it'll be less than 1. Since I moved the decimal once, made it 10 times bigger, I have to essentially make that log 10 times smaller, which is 1. And the answer is 10.101 gigaliters. Now let's look at one where the front, or the number itself, is less than 1. We have two significant figures in that measurement, and therefore when writing it in scientific notation, we're going to have to write it in two significant figures. I'm going to make that number bigger because you put the decimal to the right of the first non-zero, and therefore it'll be 1.0. 2 sig figs in that number, 2 sig figs in the above number. I moved it over twice. I made the number bigger. Therefore, I make the exponent smaller. One way to say this as well is 10 to the 0 is 1. So I can rewrite this top number as 0.010 times 10 to the 0 grams, because 1 times itself is itself. Hence, I made that number bigger. I made this number smaller. Now we want to put it in engineering notation. And engineering notation is, again, powers of 3. And when it's negative, times 10 to the negative third is milli. Negative 6 micro. Negative 9 nano. There's different ways you can look at this number here, but knowing that engineering notation, that front number has to be between 1 and 999, and that power has to be power 3. I can't make that front number smaller, meaning if I make that 1.0 to 0.10, it's not going to, the front number is not going to be between 1 and 999. So therefore, I am going to make it larger, and we're 1 off from this number, and so I'm going to make that smaller. Ten to the negative 3 is milli. So this is synonymous with milli, meaning you replace that with milli. You don't write both, but one is synonymous with the other and replaces the other. Now, unfortunately, this is not 100% right. As we look back, that has 2 sig figs. This has 2 sig figs. Therefore, our answer has to have 2 sig figs as well. So I'm going to put a decimal right there. Therefore, that 0 at the end is significant.